All right, this is 6-5, conditions for rhombuses, rectangles, and squares. So a quadrilateral is a polygon with 4 sides. Cross out the figure that is not a quadrilateral. This is not a quadrilateral. So a diagonal is a segment with endpoints of 2 non-adjacent vertices of a polygon. The word diagonal comes from the Greek prefix di, which means through, and gonal, which means angle or corner. So circle the polygon that has no diagonal, and that would be a triangle. Circle the polygon that has 2 diagonals, a quadrilateral. Let's draw the diagonals from the following with 1 vertex. So if I choose this vertex, here's a diagonal, and here's a diagonal. This one, if I choose this vertex, here's a diagonal, here's a diagonal, and here's a diagonal. And if I choose this vertex here, here's a diagonal, here's a diagonal, here's a diagonal, and here's a diagonal. So in a pentagon, there were 2 diagonals. In a hexagon, there were 3 diagonals. And in a heptagon, there were 4 diagonals. So if a diagonal of a parallelogram are perpendicular, then the parallelogram is a rhombus. If one diagonal parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So insert angle symbol into the parallelogram at the right to illustrate these 2 theorems. Insert congruent marks to illustrate 617. All right, so for perpendicular, here is the symbol. And then for congruent, here is the symbol. Done. If ABCD is a parallelogram and AC is perpendicular to BD, then we know this is a rhombus. If ABCD is a parallelogram and we know angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4, then it is a rhombus. So if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. Okay, so insert marks at the right angle symbols to illustrate this theorem. So if this is a rectangle, we know we have 4 rectangles here, 4 right angles. So these must be congruent. All right, so if ABCD is the parallelogram, then we know ABD must be congruent to AC. All right, now if the parallelogram has diagonals that are both perpendicular and congruent, it must be a square. Okay. So let's draw a parallelogram in the box, labeled angles and the measures. We may use a protractor to help make accurate measures. So we want a parallelogram whose measures are 20, 160, 20, 160. Okie dokie. So how about we draw something like this? So this is 20 degrees, 160, 20 degrees, and 160. All right. You do not know the lengths of the sides of the parallelogram. You do not know the lengths of the diagonals. The angles of a rectangle are all right angles. The angles of a square are all right angles. What can we conclude about the parallelogram being a rhombus, a rectangle, or a square? No. So the parallelogram cannot be a rectangle or square because it does not have 4 right angles. There is not enough information to tell if it's a rhombus. All right, problem number 2. All right, so for what value of y is parallelogram DEFG a rectangle? So for DEFG to be a parallelogram, the diagonals must bisect each other. So EG equals 2 times 5y plus 3, which equals 10y plus 6. And DF equals 2 times 7y minus 5, which equals 14y minus 10. So for this to be rectangles, the diagonals must also be congruent. So therefore, we can set these 2 equations equal. 10y plus 6 equals 14y minus 10. If I subtract 14y, and if I subtract 6, I get negative 4y equals negative 16, and then I get y equals 4. So the value of y is 4. All right, so suppose you are a volunteer building team at the right. You are helping to lay out a square play area. How can you use properties of diagonals to locate the 4 corners? So you can put 2 pieces of rope that will be diagonals of a square play area. Cut them to be the same length because a parallelogram is a rectangle if the diagonals are congruent. Next, we could join the two pieces of rope at their midpoints because a quadrilateral is a parallelogram if the diagonals bisect each other. You move the diagonals so they are perpendicular because a parallelogram is a rhombus if the diagonals are perpendicular. All right, so I think I have now just created a square. All right, so name all the special parallelograms that have each property. All right, diagonals are perpendicular, diagonals are congruent, diagonals are angle bisectors, diagonals bisect each other, diagonals are perpendicular. So we're going to put a check in the box if the parallelogram has that property and X if it does not. So a rectangle has properties B, D, and that's it. A rhombus has properties A, C, D, and E. And a square has all of these properties. And that's the end of this section.